Hey guys, welcome back and you're watching Triple E. This is the sixth part of DC generator in which I will be explaining about the compound type of DC generator. In the previous videos, I have already explained about the different two types of DC generator, that is separately excited DC generator in which the field was excited externally, and the other one was self-excited DC generator in which the field winding is excited with the help of armature itself. And also I have explained about the shunt type of DC generator and the series type of DC generator in detail. If you want to check out those videos, please click on this I button. So in this video, I will discuss about the compound type of DC generator, which is classified into two types. One is called as the long shunt and the other one is called as the short shunt. So let's start the video. So in case of long shunt, the shunt field winding is connected in parallel with both armature and the series field winding. So if you see here, this is the shunt field winding, and this field winding is connected in parallel with the combination of armature as well as the series field winding. So this is the series field winding. It is connected in series with the armature, and across this whole combination we connect the shunt field winding. So such a type of DC generator is called as long shunt DC generator. So in this, again, what we are supposed to do, we need to find out the equations for the currents and the equations for the voltage. So these two, the current IA, we have to find an expression for it, and the voltage EG, we have to find an expression for it. So let's start it. Now before that, let me tell you what are the resistances here. So the shunt field winding has a resistance called RSH. The series field winding has a resistance called RSC, and the armature winding also has a resistance called RA. Okay, other things, as I have already discussed earlier, we already know what is IA. IA is the armature current, ISC is the shunt series field current, ISH is the shunt field current, IL is the load current. And this is the terminal voltage, which is VT. And then EG is the induced EMF in the armature. So let's derive the expression for current first of all. So as you can see here, IA current is equals to, now if you see here, this IA current is same as ISC current, since the series field winding is connected in series with the armature. So the current which is generated here will be the same current which will flow here. Now when the current reaches to this node, it divides into two parts. One is IA and the other one is ISH. So we can write IA is equals to ISH plus IL. Right? So this is the expression for armature current. Similarly, if I tell you how to find out ISH current, so ISH will be found out based on what is the voltage across this. So what is the voltage across this terminal? It's nothing but VT. So we can take this VT divided by RSH will give us the shunt field current. Now coming to the voltage, that is EG voltage. Now we know that EG is the generated voltage. So it has to take care of the terminal voltage, plus it has to take care of the armature drop in the armature. Also it has to take care of the drop in the series field winding, since it is connected in series with the armature, and the V brush drop. So we can write the equation of EG as VT plus IARA plus ISC RSC plus V brush. And as I told you that ISC is same as IA, so we will replace this ISC with IA. So the equation will become VT plus IA into RA plus RSC plus V brush. So this is the equation of the generated voltage. So we need to always derive the equations for armature current and the armature voltage. Okay. So this is how we do the means equations finding for the long shunt DC compound generator. Now let's see the next one, that is the short shunt compound generator. So if you see here in the short shunt, the shunt field winding is connected in parallel with the armature winding only. if we see here, this is the shunt field winding. So it is connected across only the armature winding, correct? The series field winding is connected in series with the armature, but the shunt field winding is not connected across this series field winding. So hence it becomes a short shunt compound generator. So here again we will mark the RSH, that is the shunt field resistance, RSE, that is the series field resistance, and RA, which is the armature resistance. And here this is terminal voltage. So let's find out the equation for first current, that is IA current. So IA is equals to, if you see here, IA at this node, the current is dividing into two parts, that is ISH and ISC. So ISH plus ISC. And we can see here now this ISC is the same current which flows towards the load. So we can write it as ISC is equals to IL. Hence, IA will be equals to ISH plus IL. So this is the expression for the armature current. Now let's see for the voltage. So EG voltage will be equals to, same thing, EG voltage has to supply the load, correct? So it will be equals to VT plus it has to take care of the armature voltage drop. So IARA drop plus it has to take care of the ISC RSC drop, that is the drop in the series field winding, plus it has to take care of the V brush. Now here we cannot substitute ISC same as IA because ISC is equals to IL. So we will keep the equation as it is. So this is the equation of EG. Now let's try to find out how to calculate the ISH current. So to find out ISH current, what we have to see across this winding, what is the voltage we need to find. So if we get to know the voltage here, we can find out what is the current flowing here. Now if you see here, this is the voltage which is across the series shunt field winding. Now what is this voltage? This voltage is equals to the generated voltage minus the drop in the armature minus the V brush drop divided by RSH. This is one way of writing. The another form of equation I can write to find out ISH is, I can calculate the total voltage which is present here. This is nothing but VT. And what is this voltage? This is also the voltage which is present here, that is ISC RSC. So if I say VT plus ISC RSC is the voltage which will be the voltage across the shunt field winding, that is RSH. So this is the another form of equation which we can use. So we can use these two equations to find out ISH. So these are the two types of DC compound generator. So with this we finish the types of all the types of DC generator. So that's all for today, and remember to work hard to see the magic. Thank you so much for watching and see you in the next video.